what we had studied in the last class? Hello, am I audible?
Yes, ma'am.
Okay, great. So, आपके पास जो PDF है, आप उसका पेज नंबर 1 मिनट सब लोग, everybody, please take out page number 44 of the PDF which you have with you. Okay. Now, very important thing which you all have to remember is point number 3, which is continuity in an interval. Okay. A function f is said to be continuous in closed bracket AB if f is continuous at each and every point of AB. Okay. So what does this open interval mean? In the first point of third point of A में, okay, so I'm writing it once again. First thing is given that a function f is said to be continuous in this. This is known as an open interval. And what does it mean? It means that we are considering all values between A and B, but we are not considering A and B, which means if it is like 1 to 4, then we are considering only 2 and 3, but not 1 and 4. Okay, so this is known as open interval. So it is, यहाँ पे ये बोल रखा है, it is said that a function f is said to be continuous. In this particular open interval, a function is said to be continuous when at each and every point of AB, which means at 2, at 3, I'm here giving like this example. So in this from 2 to every point like 3, 4, infinity से पहले वाले number से यहाँ तक जो है, the continuity will retain, but not at the point 1 and infinity. This is meant by an open interval. Now, if we talk about the second point which is given, a function f is said to be continuous in a closed interval. What do you mean by closed interval? This symbol is for closed interval. So you can note here somewhere in your register that the closed curly these brackets, this denotes open interval where we do not include the values which is given here and here, but all of them between them. And this is known as closed interval, where we include all the values including these two. For example, in this particular thing, we will include A and B, and we'll also include all the values which come between them. Now, in this 3 points are given. For this, it is clear, for this first part, it is clear that in an open interval, at all the points continuity will be satisfied. The graph will be, the function will be continuous at all the points, each and every point. But in this case, there are 3 conditions again. The first condition is f is continuous in the open interval. It should be continuous in the open interval as said in the first point. After that, the second point given here is f is right continuous at a. Limit x tend to a plus fa. So what does it mean? That LHL should be equal to the value of fa, which means that हमने कल पढ़ा था limit x tending to something a minus fx should be equal to the value of the function, which means जो मैंने कल आप लोगों को एग्जाम्पल दिया था, ये वाला, इसमें एक पॉइंट है, यहाँ से जा रहा है, ये LHL वाली वैल्यू आ रही है, ये RHL वाली वैल्यू आ रही है, but they both are coming at the same point. So from here we can assume a minus, and from here we can assume a plus. So over here, this condition should be satisfied. And also one more condition should be satisfied. The third one over here is RHL should also be equal to FA, which means limit x tending to A plus Fx should be equal to Fa. So by combining all these three things that we have studied in this part, we can say that LHL should be equal to RHL, which means left hand limit should be equal to right hand limit, and it should be equal to the value of the function at point A. Now, it means that we can write it as, so the simple thing that we have already written in the yesterday's class, जो मैंने आपको बताया था कि किन्हीं special cases में लगता है, वो है limit x tending to a minus fx is equals to limit x tending to a plus fx is equal to fa, which means that when all these three are equal to each other, which means for instance if we take 8, so if all these values are 8, then we can say that it is continuous in the open interval, in the closed interval, and for it one more condition is there, that it should also be continuous in the open interval. So this is the theoretical part. Now I would like to make you do several questions which will clear this thing in your mind. So write it somewhere. It is already in your notes. Now we'll try some questions which are really beneficial for understanding this concept. Okay, so here we go. Now I am writing a question and then we'll understand it, how it is applicable. Okay, so first of all, the question is, we are given a function fx. Write it along with me so that we can discuss it later, and then you'll write the solution later on. We have a question over here like this. The function's value is this when x lies between 0 and 1. And the function values is this then the function lies between 1 and 2. The x lies between 1 and 2. Now what does it mean? We are given a condition that in this particular case, the value of function is this, and in this particular case, when the value of x lies between 1 and 2, then the value of the function will be this. So how are we going to solve it? And the question says that discuss the continuity of the function at x is equals to 1. So we have to discuss the continuity. Discuss the continuity of this function fx at point. We are given a specific point so that we can discuss the continuity over that point, and that point is simple as x is equals to 1. So at this point we have to discuss the continuity of this function. Discussing the continuity means that we have to say whether we have to find that whether it is continuous at this point or not. After solving this question, we'll get the answer that it is continuous or not. So how we are going to solve it? The first thing is that we know that we are given a LHL here, a value here, and an RHL here. How we get to know this? LHL. LHL is left hand limit, right? Now, limit x tending to 1 minus. So why have I written 1 over here? Because, okay, so I'm asking randomly somebody, Sanjana, unmute yourself.
Yes, ma'am.
Okay, so what is the value of x which is common between these two? Is it 0, 1 or 2? 1, exactly. That's why I have written 1 here. If 0 would have been common between these two, I would have written 0. And if 2 would have been, or if any number would have been common between these, so I would have written that number here, right? So that's why I have written, I should make it more clear, wait. So first of all, we'll find LHL, which is the left hand limit. Now limit x tending to 1 minus. Now you understand now why I have written 1 over here, because it is common in these two. Now why I have written minus, because we are finding LHL. Now how we will do this? When we'll write the function here, we'll substitute the value of 1 minus, where the value is less than 1. What do you mean by 1 minus? 1 minus means the value is less than 1. So here in this particular thing, in this particular value, we can see that the value of x is less than 1. So we'll write this function and we'll substitute x with 1, which means we'll do as this. So limit x tending to 1 minus 5 minus 4 is 1, which means our value over here which comes is 1. Now similarly we'll find RHL also. RHL, in this also we'll write 1, but here we'll write plus. What does this 1 plus means? This plus means that the value of 1, that the value of x is greater than 1, which means we'll apply this condition here. When we'll apply this condition here, then we'll have to write this function and we have to substitute x with 1 again. So when we'll do this, we'll receive something like this. And after that, we'll get 1 plus 4 minus 3, which is again 1. So we get this value again. And the last thing that we are going to find is FA, which is the value of function at a point, which means 1, because the value of function at a. So okay, so make a correction. At this point here, it is like this. Oh, I'm so sorry. Okay, wait 1 minute. मैंने कुछ गड़बड़ कर दी, 1 minute. Okay. So मैं ये कह रही थी, when we are to discuss the continuity of a function at some point, then we have to find 3 things. One is LHL, one is RHL, and one is value of a, value of the function at point A. So here, as I've said, that make this correction. So here the value of x lies between 0 and 1, and it is less than or equal to 1. So when we're talking about the value of the function at point A, which means that we are talking about the same function fx minus 4, because only at this point the value can attain the x can attain the value 1. So 5, substituting 1 in place of it, so we'll get 1. Now we can see that here the 1 is coming, the value is coming 1. Here is the value is coming 1, and here again the value is coming 1, which means that these 3 values, LHL, RHL, and the value of the function are 1 at this point. So we can say that at the point x is equals to 1, this function is continuous. This fx is continuous. Okay. Now let's do another question. Have you all written this down in your registers, or shall I wait? Somebody unmute and tell me.
Yes, ma'am.
Okay, so I think everybody. Okay, you have written. Okay. Now, next question is, so basically in this type of question, we have to find LHL, RHL, and value of function at point A. Now, a very easy question again is this. Question is, discuss the continuity of the function again. Function is given as 1 by 2 minus x when value of x lies between, value of x is equals to and greater than 0 and it is less than half. After that we have another thing, 1, x is equals to half पे, value is 1, and uske baad we have 3 by 2 minus x and half x and 1. So what we have to do, at point x is equals to half, we have to discuss the continuity of this function. So again, like the previous question, what we are going to do. Okay, so Shruti, unmute yourself.
Yes, ma'am.
So at what point do we need to find the continuity of the function?
But I didn't get
At what point, like at what value of x do we need to find the continuity of fx, the function?
half.
Exactly. So that's why what we'll write over here, limit
Limit x tends to half.
minus, if we have to find LHM. Okay, great. So, wait. Mummy, thoda dheere bolna, please. Okay. Now we have to find the value of LHL, right? So limit x tends to 1 half minus, because we have to find the value of LHL over here. Now, when the value of x is less than half, it is less than half in this case. When the function is half minus x, then this particular case, this particular situation is adjusting. So we'll substitute x by half. And what is the value that we get here? 0. If we have to find RHL, which means we have to find limit x tending to half plus. So in these three, where the value of x is greater than half, in this particular case. So here, we'll substitute x again by half and we'll get the value 1. 3 by 2 minus half is 1. Now, if we have to find the value of function, which means FA, FA is here half. So at what point half, the value of x is half. So it is at this point when the function's value is 1. So we'll easily write that it is the point 1, which means that we are obtaining these two values, RHL and the value of the function, are equal, but 0 is not equal to them, which means that the function is discontinuous at the point x is equals to half. So when the value of x is equals to half, then the function fx is discontinuous, because these three entities are not coming equal to each other. If it would have been 1, then it would have been continuous. Is it fine? So in this type of question, you just have to find three things. One is LHL, which means at whatever point you have to find or discuss the continuity, you just have to write that point and do minus, plus, and the value of at that point. And minus means when the value of x is less than it, plus means when it is greater than it, and equals to it means when it is equals to it, which is given in this question. Okay, so can I rub it? Okay. Now I am giving you one question. Try it for 5 minutes or take 3 minutes, and then we'll discuss it. And whoever gets an answer, unmute yourself and tell me. Okay. So the third example that I'm going to give you. Okay, so before giving you a question, let's do one more thing. Okay, so before giving you a question, let's discuss one more type, and then I'll give you this question again. Okay, so we have a question: find the value of k so that fx is continuous. Okay, so I'm writing the function over here. X square minus 9 upon x minus 3, x is not equal to 3. Now this question is slightly different from the other two that we have discussed already, and at this point it is equal to 3. Now the question is, we have to find the value of k. What will be the value of k so that fx is continuous at point x is equal to 3. So in the last two questions that we have already discussed, we have to discuss the continuity at some point. So उसमें हमारे पास दो आंसर होते हैं, या तो है कंटिन्यूस या फिर नहीं है, ठीक है? जैसे अभी हमने देखा कि एक में थी एक में नहीं थी. इसमें वो बोल रहा है कि it is continuous at this point, then we have to find the value of some unknown value k. इसमें क्या है? इसमें वो बोल रहा है कि कंटिन्यूस है. इसका क्या मतलब है कि what do you mean by being continuous? अभी तक हम ये देख रहे थे कि वैल्यू जो होती है वो इक्वल हो जाती है if it is continuous, ठीक है? Now here there is no affair of LHL RHL, because here we are giving a different thing which is equals to and not equals to. तो हमें इसमें LHL RHL नहीं लगाना. We just have to apply a simple thing over here, which was the first standard formula which I told, जो हमें अक्सर यूज करना पड़ता है, which is limit x tending to. Okay, so what will be the number that I will be writing here? Okay, so I'm asking somebody, Sunidhi, unmute yourself.
Yes, ma'am. It's a 3.
So what will be the number which I will write here?
3. 3 minus for left hand.
3, great, because no. Now in this particular question, we will not use that LHL, RHL minus plus wala cheez. That was for the question where we had less than, equal to, less, greater than. इस type के questions में we were using 3 minus, 3 plus and the value of function at this. In this type of question, when it is given that it is equals to or it is unequals to, it is not equals to, in this type of question, we'll directly use the standard formula, which was this one, if you remember. Limit x tends to 0, fx is equals to fa. This was the first standard formula that I made you write. So this formula we are going to apply in this case. Whereas in this case, we'll apply that formula where LHL is equals to RHL is equals to fa. Right? Now, like Sunidhi said, it is correct. Here we'll write 3. Okay. So what will be the function here and what will be the value here? Limit x tends to 3. What we'll write, what is the function that is given to us? The function which is given to us is x square minus 9 upon x minus 3. Whereas the value of function at this point a, which is 3 in this case, it is given as k. Simple. So what we have to do, we have to find this value and what will it come equal to k, because we know that it is continuous. So in this we are using reverse psychology, and here we'll do, in that question we were proving it equal. Here it is already proved, we are finding a value through it, right? So in this case, we'll solve this now. So x square minus 9. So how can I simplify it further? You might have heard about the formula a square minus b square is equals to a minus b, a plus b, right? This formula, a square minus b square is equals to a minus b, a plus b. Wait 1 minute. So I'm talking about this formula. Now we'll apply the same formula here. X minus 3, x plus 3 upon x minus 3 we already have here. In order to cancel this out, we have simplified it. So now we have limit x tends to 3 and x plus 3. Now when we have this, what will we do? आप लोगों ने लिमिट्स में पढ़ा है ये. मुझे बताओ इसका आंसर क्या होगा? Anybody? कौन बोल रहा है? I'm not able to hear.
6.
सॉरी, मुझे सुनाई नहीं दे रहा. कौन बोल रहा है?
Shruti.
ओके श्रुति. हाँ, तो आप थोड़ा तेज बोलो, मुझे सुनाई नहीं दिया.
Answer is 6.
Great. Answer is 6. Now, what will be the value of k? It will be 6. As simple as that. Okay. So, we have discussed 3 questions. In the first question, we have to discuss the continuity at some point, and we prove that it is continuous at that point by finding LHL, RHL, and FA at the particular value. After that, in the second question, that was discontinuous. Again, we proved it. In this question, it is given that it is continuous, and by that, we made these two entities equal, and then we found out the value of k. Right? Now I'm giving you all a question and 3 minutes time. So you try that out, and I'm damn sure you will figure it out. So the question that you have to do is find the value of constant k. Again, we have to find the value of k so that the function fx is continuous at point x is equals to minus 1. At x is equals to minus 1, that is, this function is continuous, and I'm giving the function also. X square minus 2x minus 3 upon x plus 1 k. This is when x is not equal to 1, and this is when x is equals to 1. So we have to find the value of k when function is continuous at this point. So like the previous question, you just have to continue in the same way. So try it out. You have 3 minutes, and then after 3 minutes, we will discuss it.
Minus
किसी का
2.
Minus 2. No, it's incorrect. कोई बात नहीं. और किसी का आया?
Even I got minus 2.
Okay. Minus 2. Okay, let's see. ठीक है. Okay. So again, in this question, we'll do the same thing. We'll proceed in the same way. X tends to minus 1 because we have to find at this point. Now, we have function here, and we have to find at this point, right? Limit x tends to minus 1. Fx is x square minus 2x minus 3 x plus 1. So this quadratic equation. So how do we solve it? We factorize it. So x square minus 3k ऐसे factors जिन्हें minus करने पर 2 आए. So this is this. I don't think there is some problem with this factorization. Anybody wants to ask something about it? Okay, so we'll take x common, x minus 3 minus common, x plus common, x minus 3, x plus 1. So we'll get, I'm writing it over here, limit x tending to minus 1, x plus 1, x minus 3 upon x plus 1. So over from here, we'll get the value 3. Oh, I'm so sorry. So sorry, I was okay. So when we'll keep the value of x here, we'll get minus 4, right? And the value of k will be minus 4. Is that fine? This after cancelling this, we have kept the value of minus 1 in this, and then we have got our answer minus 4. Okay, so can we end this meeting and start again for another 15 minutes?
Okay, ma'am.
Okay, sir.